Hello, this is Miraj Patel, and today we're going to be getting our last and final unit, which is Unit 14, and it's going to be all about gas laws, and today we're going to be specifically talking about pressure. And so, out of these three shoes, which shoes should a person wear if they want to create the most pressure on the floor? And I'm just going to give you the formula for pressure, and we're going to talk about it. And so pressure is force over area. So the force of the force that's going on and the area that it's being pushed onto. So if you think about this little formula and these separate shoes, these three shoes, um, high heels, because they have this little heel, they have a very little area that they're going to put the force on, and the force is obviously going to be your weight. So, because there's a high amount of force and a very little area that the force is being distributed on, only this little heel and just this little bottom is where all your force is going on. This creates a lot of pressure. But these two shoes, snowshoes, they have high surface area. So notice how snowshoes are very wide. They have a bigger area, and your force is your weight. So this would make it less pressure. And boots have like a medium pressure because their area is also large, but the force is always the same because if someone weighs the same, they have the same force, but the area changes, and depending on the change in the area, if the area is smaller, there's more pressure because we're dividing the same number by a smaller number. So, so the correct answer is the high heels because the high heels, because there's so much force or your weight on such a little point like these two, that it creates the most pressure. So high heels push a lot on the ground, but shoes or sneakers and snowshoes don't have as much pressure because they distribute the force on such a large area. So that's why high heels create a lot of pressure because it's all the forces distributed on one point. And we're going to talk more about pressure, but in gases next. And pressure is force over area, and in gases there's always a bunch of little particles, and they're always bouncing off the side of a container, and the little force of them actually bouncing off creates pressure. And we're going to be talking more about this. And gas pressure is caused by collisions with the walls of the container. So as these particles bounce around, they push force out onto the container, and this causes pressure, gas pressure. And here we're going to talk about atmospheric pressure, or pretty much the weight of the air. And so even though air is super light, air actually does cause pressure. And so pretty much air, because there's so much air above us, that it actually, and the gravity, it actually pushes down on us and has some pressure. And there's this cool little diagram here. And so basically we have Mercury in the center, and we have this test tube, which is a vacuum, so there's no air inside. So we basically take a test tube with nothing inside, literally no air, and we put it in this mercury. And so basically the atmospheric pressure, so the air pushing down normally on us, pushes down on this mercury, and a different amount of mercury will go in depending on the pressure. So if there's high pressure, this mercury would be higher because there's more weight pushing down, so more of the mercury goes up. And at normal sea level, there's happens to be 760 millimeters of mercury in these like little test tube apparatus thing. So pretty much because of the air and the force of gravity pushing it, pulling it down, the mercury in this tube goes up to 760 millimeters, and that's a measure of pressure. So at sea level, there should be 760 millimeters of mercury in there because, again, the air or atmospheric pressure is pushing down. And another cool thing about pressure is that pressure, air pressure, actually affects your ability to drink liquids out of straw. And so this bottle has no cork in it, but this one does have a cork in it. And so in this one, you can't suck out any water through the straw because there's no air pressure. Because the air, when you suck liquids out of a bottle or a soda bottle or anything, the air pushes down on the liquid so that it can come up the straw. But if there's no air to push down, then you can't suck out of a straw. So that's another cool thing about atmospheric pressure. And again, with the mercury model, Evangelista Torricelli created this way of measuring air pressure using mercury, and he developed in 1643, just as a fact. And at sea level, there's other units. So we have ATM, which is just atmosphere, so 1 atmosphere at sea level is just regular. Then we have 760 mmHg, so at sea level, it can be 1 ATM, 760 mmHg, or 760 torr, and this is named after Torricelli, his last name. Or it can be 101.3 kilopascals, and a pascal, or pascal, is just 1 Newton of force per a square meter. So there's so this is 101.3 kilo, so 1,000 pascals. And then we have 14.7 psi, which is sort of like the imperial measure. So these are all sort of metric, and these are what we'll be using, but just as to give you as another reference, it's 14.7 pounds per square inch. So 14.7 pounds on 1 square inch. And here we have another diagram of the atmospheric pressure. And so the difference between these two is that this one is at the top of Mount Everest, and because we're at the top of a mountain, there's less pressure or air pushing down. So because there's less force pushing down on this mercury, less of it goes up into this tube here. So that is why the level in mercury changes with pressure, because depending on the air or force pushing down represented by these arrows, if we go at a higher mountain, because there's simply less air above us, and because there's less air affected by the gravity, so there's less force pushing down. So that is why on mountains there's less atmospheric pressure, and that's why on mountains there's less air pressure than on sea level. Because on sea level there's simply more air above us, so there's more air pushing down on this mercury to cause it to go up. So that's why it's a lower number here. And so now we're going to be talking about gas pressure, and gas pressure is affected by 3 things: number of particles, volume, and temperature. And so you can think about these, or pressure, all in terms of collisions. So so pressure, if we increase the number of particles in a balloon, so just think about a balloon, if we increase the particles, because there's more and more particles bouncing along the walls, there's more collisions, and so the pressure increases also. So particles, if we simply just think about adding more air to a balloon, there's more collisions, so the pressure increases and causes the balloon to expand. Or you can think about a car tire also. If we add more air, the tire will be more stiff because there's more collisions with the tire. Then think about pressure in terms of volume. So imagine we had a container with the same amount of air, but we made it much larger. So like we put the same amount of air in like a larger balloon. So like we have this little party balloon, and then we took it and put it in a very large balloon. Because if we increase the size of the container, these particles have to travel farther to hit them. So because they have to travel farther, it takes more time for them to hit them. So there's less collisions. And so if there's less collisions, there's less pressure. So if we increase the volume of a container, then that means there's less pressure because there's less collisions. And now the final thing is temperature. So temperature, increases the speed of the particles. So if we increase the speed of the particles, they're moving faster and faster. So if they move faster, they'll hit the container more and more often. So if they have more collisions with higher temperature, there's an increase in pressure. So remember these three trends and how they affect pressure. And just remember, volume is the only inverse relationship. Temperature and particles both increases pressure if we increase particles. They're direct relationships. But volume is opposite. It's an inverse relationship. So if we increase volume, we decrease pressure. And then also another way to remember temperature is think about your car tire. If you ever drive, and if you notice how in the winter, especially in Florida or anywhere you go, that if you go in like when it's a cold day, the often in the morning your car will say that your tires are flat, but as the day warms up and sunlight, hits your tire and warms up the particles, the pressure will increase, and by the afternoon when you're leaving school, your tires will seem like your car will tell you that your tires have enough air in it. So that has to do with temperature. Because the temperature decreased in the morning, the pressure decreased. But as the day went on and it warmed up, the temperature increased, so the pressure increased, and so your tires were again stiff again. So that's how your car pressure can change, or car tire pressure can change throughout the day because of temperature. And here's a quick quiz to see what you learned. Gas pressure is affected by temperature, volume, molar mass, temperature, number of particles, volume and the size of container, or temperature, volume, and number of particles. And I'm sure most of you know that just from talking about the last slide, you saw that there were three things that affected it. And we just talked about temperature with the car tire example. Then remember, we talked about number of particles, so just think of a balloon. And then we also talked about volume, and so how volume is an inverse relationship. So because if we increase the size, there's less particles. So gas pressure is affected by temperature, volume, and number of particles, which we just talked about. So temperature increases speed, so they hit more often, more collisions, higher pressure. Volume increases size, so if we increase size, there's more and more room, so it takes them longer to hit, less collisions, less pressure. Number of particles, so simply if we add more air to a tire, there's definitely more pressure because they hit more often with the container. And so gas pressures, just think about collisions with the container, and then you'll understand it. And so here we have a conversion question. If one ATM is 760 mmHg, then how many ATMs is 747 mmHg? For this one, we're just going to go ahead and do the conversion because you have to know how to do it in order to solve these types of problems. So these problems are conversion problems, and we've done a lot of converting in chemistry, and you might not know it, but this problem is super easy. After doing stoichiometry and all that stuff, you should know how to do this in your sleep. So it's the same exact thing. We first have to write down what we have. So we have 747 mmHg. We write that first. And remember, whatever's on the top of the first fraction goes on the bottom. So on the next fraction, on the bottom goes mmHg, and on the top goes ATM. And you use these numbers that they give you. So 1 ATM and 760 mmHg to go with the corresponding units. So 1 goes with ATM, 760 goes with mmHg, and you simply do 747 divided by 760, and you should get an answer of 0.982. And just as a side note, if you did not have a calculator, you could deduce the answer by using your logic. And if you know that 1 ATM is 760 and this is 747, so this is slightly less than 760. You know it has to be less than 1 because 760 is 1 ATM. This is 747, which is only about 13 less than 760, only 13 less. And so the answer should be close to 1, but a little less. So the only answer that's very close to 1 and less is C. So you could have figured it out if you didn't have a calculator just by using your logic and reasoning skills. And so remember, when you're doing math and anything, you should always have like some way to check it. So see if you're in this right ballpark range or set of values. So just as a side note. And so that is it for this video. So we talked about pressure and how pressure has to do with force divided by area. And so we talked about mmHg, and mmHg is a measure of pressure using mercury and atmospheric pressure. And so pretty much the air pushes down the mercury, which goes into the test tube. And depending on the amount of air pushing down on that beaker, there's more or less, depending. If there's more force, then the mercury goes higher. If there's less force, it goes lower. And then we also talked about gas pressure and how it's affected based off of temperature, number of particles, and volume. And it also has to do with the number of collisions with the surface of the container. So if there's more collisions, higher pressure; less collisions, less pressure. So the next video is going to be all about combined gas laws, and there we'll be getting into some more calculations. And so I'll see you next time, and I hope you have a good day, and I hope this helped you.